நான் அட்மிட் பண்ணிட்டோமா?
Hi guys.
Right.
We'll wait for a minute. It's already 9:30 or 8:30. You know what? Several of you have not come. I don't know why. Let me check. Yeah, they are coming. Nice, Rishabh. Yeah, what was last week's homework? Let me quickly open the thing and you can let me know if you have questions. Okay, guys. Did I explain to you? See, I started posting reviews. I don't know how many of you saw for the end of course exam. End of course exam in the sense you all will take Algebra 1 EOC, right? For that, I have started posting reviews. Did you guys see that?
Yeah.
It's not urgent. It's not immediate. You can take it at your own time. I have given you till March 5. But at the same time, take those seriously. It'll be so helpful. Meaning, what I have seen always with Algebra 1 EOC is kids forget whatever they learned 5 months back, 4 months back. So that's why I thought, okay, we'll go back to exponential functions, revise it. And then I also posted for exponential functions and polynomial functions. So now I'll go back and put in quadratic functions, domain range, so you can revise it a little bit. And by the time April EOC comes, you will all be prepared and school will also revise then. So it will be a nice revision. Make sense? But please keep doing that. It's good for you. Okay. Yeah, take it seriously. Do whenever you have the time, right? Because see, another point is PSAT Algebra 1 is the heart of algebra PSAT. So anyway, you have to be thorough with Algebra 1. So how many ever times you revise, it is a boon for you. So if you want to do well in PSAT, if you want to show a difference, yes, do these. It will really help you. Okay, but if it is hard, bring it back and ask, hey, I did not understand this. Let's do this. Let's do that like that. Okay, so we did multiplication and division of polynomials, correct? Okay, good. Rishit, what are they doing in school?
We're doing quadratics right now.
Okay, so what, graphing or factoring or what?
Like so far we're learning how to graph it. with the zeros and stuff.
Okay, okay. So I'm going to start that today because after division of polynomials, we have only quadratics. Yojit, what are you doing in school?
Factoring.
Factoring of quadratics or factoring of polynomials?
Factoring polynomials, I think.
Oh, I see. How about you, Srinika?
We're also doing factoring quadratics and finding the zeros in graph.
Okay, Navya?
We're doing parabolas.
Parabolas. Parabolas is quadratics, ma. Adira?
We like just finished stats and we're doing like frequency
Tables, okay, frequency tables, okay, okay. See that one, see frequency tables, we did it, whatever you're doing now in 7th grade, ma, 7th grade class. That's what I'm seeing. Frequency distribution, right? Tables.
yeah.
Percentages, do you express it? Okay. Pranav and Mahi, what are you doing?
I'm doing quadratics.
Why so many of them are not there in today? I'm not getting it all. Okay. Pranav?
We're doing quadratics.
Oh, okay. The Mahir?
We're factoring out polynomials.
Volume. Okay. I see. So now let's go ahead and try. Okay. How about this? Suppose if you want to graph anything, right? Let's consider graphing of this. Second, that's better. Okay. So let's say you're given this. What is this? Do you know how to graph this?
It's a linear function.
I get it. So this is a linear function. The power of x is 1. It's a linear function. Okay. So how to graph this? We immediately draw a table. XY. X is the independent variable. It is just a revision. This is the dependent variable. You put any values for x, 2 negative, 2 positives, and then a 0. You put any 2 positive values, 2 negative values, and a 0. So now plug it into this equation, find out y, and then draw the coordinate plane. -3 comma -3 means we plot it in here, -2 comma -2, 0 comma 0, 2 comma 2, 3 comma 3, we draw a line. Did you get it, guys? This is what we have been doing, right? Suppose if I give you y equal to x square. Now the power of x is no longer 1. It has become a 2, right? Let it be like this or even like this, y equal to x square plus x plus 1. Here, the degree of this polynomial is what? The highest degree, right? 2. So when the degree of a polynomial is 2, right, then we get to call such a function as quadratic functions or parabolas, right? So now how are we going to graph this? Do you know how to graph this, all of you? Would you be able to, if I give it to you, would you be able to graph it, guys? Please be interactive. Would you be able to do, or do you want me to show you? It's a question. I need an answer.
Please show us.
I think I have it.
Okay, so some of you want me to show. Okay. See, I'll put x, y values. I'll draw a table. Again, I'll go to 2 negative values, 2 positive values. This time, let me put -7. 2 negative values, right? You can pick anything. And then I'll pick 0 or maybe one more. Anything you can do. Meaning, the more the numbers you choose, the better would be your table, right? 0. I'll choose 2, 6, 7. Too many values though. This is not required. Plug it in. What is y value, ma, Adira? For -7. Tell me, what is the y value for -7?
49.
Nine. Plus 49, yes. Then plus 36. Oh, I see. Okay, some of them are not well. Some of them have gone to India. That is why so many of them are not there. 36, 79, just 49. I just now remember. Some have gone in an emergency to India. A couple of them, and couple of them are not well. Okay. Let's go like this. So minus 7 is somewhere here, right? And that is a 49, but it's a plus 49. Minus 6 is a 36, somewhere down here. That's why you cannot go to too big of a value. Minus 2 is a 4. That is easier to plot. You see? And then 0, 0, 2, 4. Again, this side as well. So you see, this is how I plot the graph. You see? So this is going to be a U curve. Am I making sense? Okay, so let me go ahead and show this one. Y equal to x square. You got a graph like this. Now, can I ask you to plot a graph for this one? X minus 2 the whole square. You're going to show me, okay? You're going to plug in values and you're going to show me the graph for each of this. X plus 2 the whole square. Be careful, guys. X square plus 2. X square minus 2. And then we go ahead with minus x squared. And then what? Let me number it. You can go with that numbering. Okay, so this was 1. This was 2. Please go in order. Then only you'll understand something. 4, 5, 6, 7. If you want me to do it on the board, you have to be blatant and telling in chat or shout out. I'm fine with it. If you want to give it a try, definitely give it a try. This is just putting out the tables, plugging in values, showing a graph. Would you be able to take it? Rishit, Yojit, Mahir, Navya, Adira, Pranav. Do you want to give it a try?
I
Yeah.
can try.
Sure. Yeah, Rishit, just hold on. I will check what is the problem with your IXL
Okay.
at the end of the class. I saw your mom's message. Okay, I somehow missed it in the sense, yeah, I had too many things going on. I did not see. I'll do it now after the class. Guys, you have to let me know. Meaning, if you're stuck, immediately send a message. If you're not sure, it's okay to say, hey, I don't know. Why don't we do it together? Rishit, for the IXL thing, what is the username password you're using?
Send it in the chat.
You sent it in, oh, you will, okay.
But just the username, right?
Yeah, yeah. Okay. Um, Rishit, I sent you a message as well. You can check on that.
Okay.
You have the password with you?
Yeah.
Uh, that's the password as well. I've sent to you.
Yeah. Thank you.
Check, but at the end of the class, you're going to check and let me know. Okay. Now, did you do the graph? Because I told your mom already she was having double user IDs. I don't know why she bought the other one. I did indicate to her earlier. So maybe that you're using the older one, I feel. Check it out. Did you guys get it? I really would like to see
Now.
where you are. Huh?
It works now.
Yeah, yeah. Can I see where you are? See, don't forget that, Amma, and keep using the older one.
Okay.
By I think she got two, but one expired. Okay, where are we? Can one of you show me where you are? Are you stuck? I just need some input, guys, rather than me sitting here just like that.
I'm
I'm
on
almost grabbing them.
I'm not stuck, but it's taking me a while to like draw the graph and do everything.
Okay, but there, okay. 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 But it's nice to get these graphs out. These are the possible graphs. And there are a couple more for sure that we'll do.
Show my.
Yeah, please. I would love to. Rishit, one by one, I want to see Rishit. For some reason, I'm not able to see properly. I'm sorry. Wait. I don't know why. 1 minute, wait. If I pin, what would happen? If I spotlight, what would happen? I don't know what would happen if I spot. 1 minute, Rishit. Yes, I'm able to see. That is what. Rishit, number one is, why is it coming down the x-axis, Rishit? 2 is correct. Number one, why is it coming down the x-axis?
I didn't draw it properly.
Oh, okay. So you know that. Okay, good. 3, 1 minute. What is 3? Let me compare, please. 3 is correct. 4 is 3 is correct. 4 is x minus 2. No, right, Rishit? Oh, correct. Okay, 4 is correct. 5th, correct. 6th, yeah, yeah. Okay, thank you. Thank you, Rishit. Yes, yours all are correct. Did they go over transformations, Rishit, at school?
They did it a long time ago.
For what? For quadratics?
I mean, yeah, because at the start of the year, my teacher briefly went over everything. So,
Okay.
yeah.
We have also discussed that here, but I want you guys, I don't know whether you remember, so I thought of definitely revising this. Let's see. This is quite important. We move on. Who wants to show? Pranav, looks like you did, right, Pranav?
I did 3.
Want to show me?
Okay.
I'm not sure whether you're doing the table for everything. So let's see. Oh yeah, you're doing the table for everything. Very nice. 1, 2 is correct, Amma. 3, oh, 2 is done. Okay,
Three.
so you're doing it 3?
Isn't 3 the same as 1?
Correct. Good job. Good job. So you guys are understanding how to do. Anya, do you know how to do these?
Sort of.
Sort of. You just need to plug in values. Draw a table, plug in values. X, Y, plug in values. 2 negative values, 2 positive values. So plug in this X value here, find out what is Y, and then plot the graph. You got it?
Yeah.
So can you do that for me? Navya, did you get the graph?
Yeah, I'm still working on it.
But do you know how to do this, ma?
Yeah.
Once you're done comfortably, I can explain a little bit more. I want you to understand a little bit more on this. Done? When you're comfortable, you have to let me know, please. You have to show. We're done. I would like to see 1 or 2 of the graphs, please. Pranav is on board. Rishit is on board. Can I see others, please? Yojit, did you understand and do Yojit? No, Mama, I didn't see Yojit. 1 and 3 only I saw. 2 I did not see, honestly.
I did. I'm a little stuck on number 4 though.
Yeah. See, like that, please tell. Okay, so I'll do number 4. Okay, I saw 3, Yojit, yours. Number 4 you want me to do, huh? Okay, so I'm going to erase that off. Rishit, you're going to pay. What? 4 I'll do, Amma. So here, I'm going to draw a table. X, Y. Let me have -3, -2, 0, 2, 4. So that it's a little more part of the graph is covered. Now I'm going to plug in -3 in here. If I plug in -3, -2, the whole square, that becomes -5 squared. So that is a 25. The first one is done. Second one, -2. I have to plug in -2, right? If I plug in -2, -2, -2, means that is a -4. When I square a -4, it becomes a positive number. It's 16. Now 0 means -2 is only remaining in the parenthesis. -2, if I square it, it becomes a positive number 4. Then 2, if I substitute 2 minus 2 is a 0. 0 square is a 0. 4, if I substitute 4 minus 2 becomes a 2, positive 2. When I square it, it becomes a 4. Now I'm going to plot this graph, right? So here. So -3 comma -3 is a 25 somewhere up here. And then -2 is also a 16 somewhere up here. 0, 0 is a 4. You see? 0 is a 4. 2 is a 0. Now 4 is a 4. Do you see, guys? It moved. Actually, this is called the parent graph. This one with nothing. Do you see? There is no change. This y equal to x square, plain graph, y equal to x, like that, y equal to x square is a parent graph of the quadratic function. The function is called quadratic function. Y equal to x is called a linear function. Y equal to x square is called a quadratic function. Now, this y equal to x square plain graph is called the parent function. Now we always compare with the parent. Okay, what happened when I say x minus 2 the whole square? See this u, the bottom of the u is called the vertex. Okay, how did the vertex move? Vertex moved to, vertex was 0, comma 0 in the parent graph. Here it is 2, comma 0. So the vertex moved 2 units to the right. Make sense?
Miss Priya,
Yeah, go ahead.
can you see the ones I've done so far?
1 minute, ma. I did not. Wait, Adira, it's you, right?
Yeah.
1 minute, wait. I need to make sure you're on the video. Yeah, Adira, I'm here.
Mm,
Just show me. Yes, I can see. I can see. I'm good. Wait. I just need to see the numbers, please. 1, 2, 3. Have you marked 1, 2, 3?
this is 2,
Amma, please. Why don't you mark it, ma? It's so easy. Yeah, 2 is correct. Then
and then this one is 3.
which one is 3? I'm not able to see. Hold on.
It says 3. Hold on.
I'm checking. Oh, yeah. I need to see the graph of 3, please. 3 is similar to 1. Okay, good. Okay.
And then this one is 4.
4 graph, I want to see properly. 4 is to the right. Wait, I'm checking. Okay, correct.
And then this one's 5.
Which one is 5, Emma?
This one.
Sorry, Adira. Fifth one I
This
got.
one.
But why is it under the x-axis, Adira?
I like messed up that point, I think.
Yeah, so basically it should not go below the x-axis. That is as well important, guys. It moves only, see, it moves, see. At the end of it, I want to explain to you that if you see an added value, right, this is like x minus -2. So basically, when you're comparing, you always compare. See, this is my parent. Whenever this is my parent function, x squared. But then if you see an x plus 2, it moves to the left. Whenever you see an x minus 2 inside this bracket, right, then it moves to the right by those units. So that's what I want you to understand. What happened to 6 and 7? Nobody showed 6 and 7. One of you can show 6 and 7, right?
You see mine. There's 6 and 7.
Srinita, sure. Yeah, 6 is correct. 7? Yeah, correct. So when you look at this, right, after the squaring, there is a plus. You see, the +2 is applied to your y-axis here. Here, the +2 was applied to the x-axis because it was inside the parenthesis. Here, it was squared and then added it 2 means it gets applied to the y-axis. So the vertex moved up by 2, vertex moved down by 2 here because of a -2. Am I making sense? Now, the parent graph here, you will say move 2 units to the right. The parent graph moved 2 units to the left horizontally, right? Left, right means horizontal. Here moves up by 2 units, moves down by 2 units. Navya, did you get the graphs?
Yeah.
Okay. Now, when there is a minus, right? See, the minus is not squared here. Do you see? The minus is outside of the squaring. So, whenever it's outside the squaring, so what happens? The y value is negated. Suppose, let's say there was a point here. This y value gets negated means the point came here. This y value, the point on the graph came here. So y value gets negated means it's a reflection on the x-axis. If the x value gets negated, it's a reflection on the y-axis. It's the opposite. So here, do you see the minus was applied to the y values? So it was a reflection on the x-axis of the entire parent graph. Now the minus is inside the parenthesis here. That means which value gets negated? X comma y is your value, point on the graph. But the minus is applied to your x values. So think about a point here. This is 1 comma 3, let's say, or 3 comma 1. Let's say this is 3 comma 1. If I negate the x value, it becomes minus 3 comma 1. It comes to this side, right? If the x value is negated, it's a reflection. This parent graph came to this side. This parent graph came to this side. See, it's a reflection on the y-axis because x value got negated here. Am I making sense? Srinita, did you get it?
Yeah.
Let's see. Now, the last part of this is, how about this? Where are we on this? Let's see, and then we'll see. Y will be equal to 2x squared. Y will be equal to 2x is inside the parenthesis and then squared. There's a difference between the two. Here, in number 8, what happened? 9, what happened? Rishit, can you explain 8?
So wait, is it okay if I draw a table?
Yeah, sure.
So
Hmm.
since it's like this, it's 2 to the power of, it's 2 times x squared.
Uh-huh.
It's 1, that's 2, 2, that's 8,
Uh-huh.
3, that's 18. So because of the 2, it doubles whatever's inside of the x.
Good job. So, how will the graph be? What is it called? Do you know, Rishit? It's okay if you don't know. I'm just asking.
I don't.
Okay, no problem. See, I just want to know. I mean, this is the first time we showed you when we discussed linear functions, but it's not that you should remember. Okay, so he has the table, correct? Now, I'm going to draw his table into a graph. I want to use that space for that one. Okay. I'm going to use this table to draw my graph. 1, comma 2, 2, comma 8. So what is the difference? There's some difference between, see, the graph 3, comma 18. So there's some difference between the parent graph. What is the difference? The parent graph was like this. What do you see as the difference between the two? This was x squared. This was 2x squared. So what is the difference? What do you see? The parent graph was like this.
It's steeper.
It's steeper, correct. It became steeper. Why? Like consider this as 1. Okay, 1 was multiplied with x squared. Here 2 was multiplied with x squared. So the y values are becoming, see, for the same x value, the y value became more. See, let's see. For this graph, right, let me draw the graph for the same values. 1, 2, 3 he has drawn. So I'm going to put the same 1, 2, 3. If we put 1, 2, 3, this is a 1 because this is x square, right? X square was y. So 1, 4, 9. Here do you see 2, 8, 18? So for the same x values, when you compare the y values, they became steeper. Or I can say the graph thinned. It's like what? Meaning the graph thinned. So it was more like the 1 or 2 was applied to your x value, the y value. How do you find it out? The 1 or 2 that you multiply, right? Is it applied to the y value, y coordinate or the x coordinate? Say guys, it's okay to go wrong, right? The 1 or 2, 1 you multiply, right? 2 you multiply. That multiplication is being applied to the x value or the y value.
Why?
Why we are applying it to y? If I was to apply to the x, then it should have come within the bracket, within the parenthesis. You get it? You multiply with x and then square it. No, you didn't do this. But instead, the main function about all these graphs is x square, squaring x. You squared x and then you multiplied and assigned it to y. Do you see it? So the y value, so the multiplication of 2 was applied to the y, the vertical axis. You get it? So it's more like holding the bottom of the u and pulling it down. So what would happen? If I hold the bottom of the u and pull it down, the graph will automatically become steeper. It will become thin down. Do you get it? Am I making sense? If you hold the bottom of the u, literally you pull it down, what would happen? The u will become thin. So you know, how do I call it? I call it as a vertical stretch. You are stretching vertically. Vertical stretch by a factor of 2. Am I making sense? Okay. See, this may not be that useful right now, but if you know this thing very well and come into Algebra 2, you will be the king in Algebra 2. Okay, so they're going to just ask you to, hey, draw the table, graph it. But that's not where we want to stop. You need to understand why you're doing each thing. Okay, so there is a vertical stretch by a factor of 2. You get it? So as like that, how do I indicate this? Here there is a horizontal movement to the right, to the left by a factor of 2 in number 5. Number 6, there is a horizontal, there's a vertical movement up by a factor of 2. So by seeing the pattern, you have to start telling how the graph moves. That skill you can develop only when you understand the basic graphs. Now, here there is a difference. The 2 was multiplied and applied to the y value. So what happened to the graph? Vertically, it got stretched since you applied to the y value. Here, when you think about it, x comma y, I'm going to plot the graph. I'm going to say 1, 2, 3. He has 1, 2, 3. So I'll put 1, 2, 3. So what happens here? You're multiplying x first. So what happened? The x values changed now. Basically, 1, 2, 3 are not the x values because you're going to multiply everything by 2. So the 1 was earlier 1, right? That this was in the parent. Now the new graph, right? New graph x I need to write out. So 2, then 4, 6. Those are the new x values. For those x values, what happened to y?
Squared.
Yeah, meaning y value remain the same. Y value I won't change here because only the x value changed and the y value remained as what? The parent graph values 1, 4, 9. Right. So here when I graph it, 2, 1, 2, 1, 4, 1 minute guys, 4. Now 6, 9. Similarly, this side as well, it's like this. So what is going on here? Can one of you tell me? What happened here?
Wait, wouldn't it be 2, 4?
Is it 2, 4? Let me see. Why?
Because it's 2x to the power of 2 and 2 to the power of 2 is 4.
1 second. So you substitute 2 here. Okay, I should have taught you in a different. Rishit, to answer your question, no. But for you, it's difficult to understand that, right? Okay. How about this? We'll go with the old values 1, 2, 3 itself. We'll do your way. Okay. I'm not going to erase that. This is correct only, but I don't want to get there right now. Okay. It's a little difficult for you to understand. How about this? We'll put x equal to 1. What happens to the y value? We'll do that. Please, we'll just replace it. I'm sorry. Let's not do this. This comes in algebra 2. So let's not do that. So this is 1. So what happens to y? It becomes 4. Rishit, this is okay, right? Now you're convinced, right? You
Yeah.
put a 2 here, what happens?
It's a 16.
16.
Now you're convinced. Okay, let's please do that. Okay. Now you put a 3, 36. So now let's do 1 comma 4 like that. So we'll have our old values. I don't want to change. This change comes in the algebra 2. So let me not confuse you right now. It's a little difficult to take in. We'll do your own values, meaning the original parent values. And then we'll just plug into the graph as we did in the previous ones. So here 1 comma 4. Something feels wrong, guys. Hold on. I really want to see the change, guys. The change is not seen at all, right? Like, see, this U became thin. This U thinned down was what we understood, right? This U was thinned down here. Like that, I want you to understand for this one. If you put a, I want to see the change as well. Let me put more values. Here, something as well happens. So let me put a 0. You have a 0. Then let me put a -2. What happens if I put a -2? -2. -1 I'll put. -1 na. This becomes a 4. -2 na. It becomes a 16. So here what happens? Let's see. This is our old graph. -2. Somewhere we are losing something. Oh, okay. I know what. Okay, let's go ahead and do. -2 is a 16. -1 is a 4. 0 is a 0. Again, what happened here? 2 is a 16. 2 is a 16. Oh my gosh. So again, what do you think happened? It is also equal to?
It's a vertical stretch.
I don't want to say vertical stretch because 2 was outside and it was applied to y. Here 2 is inside applied to x. So can I say horizontally what happened? Meaning I'll say, see, whenever the multiplication is applied to the horizontal x value, I'll always say it is horizontal only. Okay. So why don't I call it in horizontal way? See, okay, let's think about it. The bottom of the U, I am pulling it down. So it's a vertically, I'm stretching it. Vertically, I'm stretching the graph. Horizontally, what happens to the graph? This was, see, vertically, if you're stretching the graph, horizontally, what were you doing? Horizontally,
Slimming.
compressing it, right?
Making it smaller like this way.
Correct. Adira shows it. Horizontally, we are compressing it. Vertically, we are stretching it. Correct? So, anytime you say vertical stretch, if the same thing is expressed horizontally, it's a horizontal compression. Similarly, this graph, right, the 2 is getting multiplied to the x, right? There, what happens horizontally? By the values, you can say the usual graph is like this parent graph. So what happened horizontally here?
It got horizontally compressed.
You're compressing it horizontally. Okay. Whereas if you put half x the whole square, You know, I'll tell you, you don't need to graph it. Okay, I'll tell you how the graph comes. If it is half x square, the graph will become like this. So what does that mean? Half x square graph. That's a horizontal
Stretch.
stretch. It will be a horizontal stretch. Otherwise, in other ways, I can call it as vertical compression. So the graph is becoming fatter. When the graph becomes fatter, see, always think about holding the bottom of the U. When you pull it down, it's a vertical stretch. At the same time, it's a horizontal compression, correct? Whereas, let's say you want to pull the U horizontally. Horizontally, see, you can see my video too. You want to pull the graph horizontally. In that case, what would happen? The graph will become fat. But what does it mean vertically? Vertically, you're compressing, patting the graph up and down. You're patting the graph up and down. Then only it will become fat and fat. So you have to understand this concept a little bit is my target for the day. Meaning, let me go back. Can I erase all of this?
Yeah.
I'll go over it again. You will understand slowly. So here, y equal to x square is our parent graph. Okay. Now, whenever I see a graph like this, what happens here? There are two things that happened. What are the two things that happened?
So
Because of the minus, what would
because
have?
of the minus, it's gonna be in the third and fourth quadrant.
It was
It can
reflected.
be reflected.
Reflected on what?
The
The
x-axis.
y value became negative. Reflected on x-axis. And then what is this 2?
It's a vertical
Vertical
stretch.
stretch
Or
by 2.
horizontal compression.
Vertical stretch. What is that, ma? What is that, Yojit?
I
What
said
is that?
more horizontal compression.
Okay, good. That is a horizontal compression. I agree. But let's go over we are only going to call this as a vertical stretch for now, please. But I did tell you that they are equal, no doubt. I wanted you to know that they are equal. But when you think about and describe the changes, right, I would really want the 2. See, because x was square and then was multiplied to 2 and applied to y-axis. You see, the multiplication by 2 was applied to the y coordinate. So I always want to say it as only vertical. Make sense? Whereas, how about this? How about this? How about this? What is this? What value was negated?
The x.
X value was negated. So the x value, take a point. If you negate the x value, what happens? The point comes here. So basically this y became this part of the y became this. So it was a reflection on, there was no change in the parent graph. Why? It is a U curve, right? The U curve became same thing. So it was a reflection on y axis. Okay, now I'm not going to get into, see, basically this you have understood, this you have understood, this you have understood. That's what I'm understanding. Okay, but see this one, let's say the same 2 is going to be multiplied inside. What happens? Again, the graph thins down here. So it is called a horizontal compression by 2. By half compression. Okay, that's what this I don't want to explain right now. So we are good with all of this, correct, guys? Can I move on? With this, it's enough. Okay, we will discuss again next week if we have time. Okay, now let's go ahead, and I really want to understand the properties of the graph, parent graph. Let's go ahead and discuss the parent graph more. A few minutes per. Let's discuss the parent graph more. Y equal to x square. In this case, right, guys? This I termed it as the vertex. Now, think about me drawing a line in between. Is the left half equal to the right half? Is the left?
Yes,
Yes.
absolutely.
So I can say it is symmetrical. And this line that I draw, right, That is called the axis of symmetry. Good job. So what is the equation for the axis of symmetry for this graph?
0.
Negative b over 2 times x.
Negative b divided by 2a.
Yeah, the x is on the bottom.
Let's not go there. What is the equation for this one?
X equals 0.
X
Oh.
equal to 0 is the axis of symmetry. Now, for this graph, what is the axis of symmetry? This graph is going to be like this. What is the axis of symmetry? What is the axis of symmetry for this graph?
Negative 2.
Yep. That is the axis of symmetry. Make sense? Okay. Now, let's consider y equal to x square plus 2. What is the axis of symmetry?
X equals
X equals
2.
0.
X equal to?
0.
2.
There are two different answers, but I really like this. Huh? What is the axis? Think about it. What is the graph? The graph,
It's x equals 2, right?
why do you think it's x equal to 2? The graph is just went up, right?
0.
Oh,
It's still x equals 0.
Up, x equal to 0 is axis of symmetry. For this one, y equal to 2x square. What is the axis of symmetry?
X equals 0.
Up, it didn't change at all. It's going to fat or thin down, right? Whenever it's a multiplication by 2 or half, right? If I multiply by half, right, the graph is going to thin down. But see, the multiplying is outside, the squared and outside, right? So the graph is going to become fat. The graph is going to thin down here. Wait. Vertically or stretching. Yes, graph is going to vertically thin down. Graph is going to, here you're multiplying by half means you're going to pat the graph up and down. Vertically you're here vertically, this is a vertical stretch by 2. Stretch means the factor is greater than 1. Here vertically you're compressing by, vertical compression by half. So it's going to become fat. Remember that, that's enough for now. So that's it here. So now we understood how to find the axis of symmetry. Now let's go ahead with this. This parent graph. Can I ask you to write the end behavior? What is the end behavior? For this one, I'm going to write. For the next one, you're going to write. Okay. End behavior is x is going to infinity. As x goes to infinity, what happens to y? Y means the graph. What happens to y? Y value. How is the y value here?
It's
Y
going to
goes to infinity.
Y goes to infinity. Good job. As x goes to minus, I'm sorry, x goes to minus infinity, I should have put. As x goes to minus infinity, what happens to y? Y goes to infinity. Good. As x goes to infinity, y as well goes to infinity. Am I making sense? How about this? I really want you to write the end behavior of this. What is the end behavior of this?
As x goes to negative infinity, y goes to negative infinity.
Y goes to negative. If you didn't understand, Navya, are you following, ma?
yeah.
As x goes to negative infinity, what happens to y? Y also goes. See this point on the graph. Y also goes to negative infinity. As x goes to infinity, what happens?
Y goes to negative infinity.
Yep, y goes to negative infinity. Do you see how to write the end behavior now? So, for a quadratic graph, you know how to graph any graph now. Suppose if I give you a graph like this, can I ask you to graph this quick and show me? Meaning, if you can be quick, we can cover a little bit more, I feel. How about this? Minus 2 x square plus 2. Okay. Can I see you graph this? Can I see you graph this? Or wait guys, let me change the number. Then only you will know the difference. Can I see you graph this quick? I really want to cover a little bit more. Let me see. Minus 2 x square plus 3. I want you to graph it. 1 second, guys. I want you to write the domain, range, axis of symmetry, and behavior. Sorry, guys, I'm back. Go ahead. Did you have the graph?
Give me a second.
But if you're stuck, let me know so that I can work with you. Rishit, for some reason, I'm not seeing Rishit. Sorry. Wait. Oh, yeah. Good job. Yes, that's right. But can you, okay. See, domain range, I'm not able to see, so you have to send it to me, please.
Okay, I'll type in the chat.
Can I show you my graph?
Yes, please. But okay. Srinita, one request, Srinita.
Yeah.
How many units it went up that you're not marking?
Okay.
Guys, do you all know how to use a calculator and graph this?
Yeah.
I kind of know how to. We're learning.
How about the others? How about the others?
Miss Priya,
Uh,
could you check my graph?
yeah, I can. Yes, Pranav, go ahead. Pranav, do you know how to use a calculator and graph it?
Yeah.
Do you know how to use a TI-84 calculator? Yes, Pranav, thank you.
I don't.
Yeah, I do.
Okay, how about
I don't.
Navya? Navya, how about you? Okay, ma. How about Navya?
No.
Do you know how to use a calculator and graph this?
Yeah.
Okay, that's good to know. But let me see. 1 minute. Wait. Who's yet to show? Okay, so can you send me the Good job, Rishit. Domain and range is correct. So we are way past half. Okay, guys. Did you get it? I want see domain range. Nobody has sent me what is going on. Navya, did you get it, ma?
I think so.
So I will go step by step. I know you all know this, but step by step of way of doing this is I'll put -3, -2, 0, 1, 2. Okay, by plugging it in, -3 square is 9. 9 times -2 is minus 18 plus 3 is minus 15. If I plug in minus 2 here, that becomes positive 4. 4 times minus 2 is a minus 8. And then add 3, that becomes a minus 5. 0 means it's a 3. 1 means it's a 1. 2 means 1 means it's a 1. 2 means 4 times minus 2 is 4 times minus 2 is a minus 8. So basically minus 5. So now when I plot this, minus 3 is a minus 15. It's somewhere here. Minus 2 is a minus 5. 0 is a 3. 0 is a 3. And then 1 is a 1. 1 is a 1 now. Somewhere something feels wrong. Yeah. Zero is a 3 is correct. If I put a 1, okay, I'm checking your all real numbers range, all real numbers less than or equal to 3. Hey, Rishit, your domain, your range had an Rishit, there was one issue, Rishit, with yours. 2 is a minus 5. 2 is a minus 5. Somewhere I have a feeling I am going wrong, guys. Hold on. Minus 2x square plus 3. So basically, what happened here? One value, something feels wrong to me. If I put a 1,
Miss Priya,
yeah,
you
go ahead.
on the graph, you put it as -3 when 0 is 3.
Ah, okay, thank you, ma. Perfectly makes sense. Yeah, I got it. Thanks, guys. So sweet. Okay, so here this should be this way. Okay. Now, domain is all reals. Okay. At your level, I really do not want to see this. Okay. I don't want you to say all reals. You should put it as an inequality. Minus infinity less than 0 is less than infinity. Whenever you have infinity, there should not be an equal to sign. These things really help you later. Minus infinity less than 0 less than infinity. This is how I want you to write out the domain, and this notation is called inequality notation. Okay. Range is Rishit, there was one problem. Y is less than or equal to 3. This is so important because it touches 3. Axis of symmetry is x equal to 0. End behavior is as x tends to minus infinity, y tends to minus infinity. As x tends to plus infinity, y tends to minus infinity. Any questions? Any questions? Let me go back. I just want to verify this. Where are we on this? Okay, if I ask you the graph, I don't want the graph now. Y equal to 3x square. What happened here? Any thoughts? What happens to the graph?
It's a vertical stretch by 3.
The vertical stretch means, so what happens to my parent graph?
It becomes slimmer.
It becomes, yeah, thinner. So vertical stretch by a factor of 3. So that's my graph. Now, let's go ahead and try one more. Y equal to 1 by 3x square. What happened to that graph?
It stretches.
It's a vertical compression.
Vertically, what would happen if you multiply by 1 by 3 means it becomes fatter, Pranav. You see what I mean?
What's the name for that?
What is it?
What's the name for it becoming fatter?
Sorry, Yojit, I didn't hear you. What was
What's
that?
the name for it becoming fatter?
Fatter, yeah. So this, let me write it down in the same color so you really understand what we are dealing with. This is parent graph. Y equal to x square parent. This one is, the next one is black color, right? So this one is vertical stretched by 3. Okay, this one is this graph, and then the green graph is vertically compressed by 1 by 3. Make sense? Okay. Now, the real problem, you know where it comes? The real problem comes only when that number is inside. This is a real problem. I'm sorry. This one is a real problem. 3x squared. Or if I put the number 1 by 3, it is the reverse here. Okay. This is a little confusing. I'm not going to deal with it this week. Okay. When the number comes inside, everything inverts. Meaning, if you just because the 3 is inside, right? This one becomes a horizontal compression by 1 by 3. This one becomes horizontal stretch by 3. So I don't want to confuse you there. So let's not take this. First, let's digest this nicely. When you multiply by a 3, it's a stretch because it's a big number. It's a vertical stretch. When you multiply by 3, when you multiply by 1 by 3, it's a small number. It's a fraction, right? So you're compressing it vertically. So vertical compression by 1 by 3. We'll have that. And then I also want you to know y equal to minus x square. What is that?
The reflection on the x-axis.
The graph becomes, the graph should be like your, which graph? Red color, the parent graph. It should be the same size of your parent graph because no other change is there excluding the reflection. Got it, guys, this one? So now if I have the format, of the graph like ax square, what is this a?
The coefficient.
Yeah, what does the a say? Meaning, we were discussing, right? Stretch, compressor, reflection. What does this
It tells whether it's compressed, reflected, or stretched.
So basically, the number value, suppose if it is 2, the number value tells it is a compression or stretch. Okay, the number is greater than 1, it's a vertical stretch. The number is less than 1, it's a compression. The number value. But the sign of that A tells whether it's a reflection. Reflection on x-axis. If there is a negative, then it's a reflection on the x-axis. Let me put it in a very methodical way. Y will be equal to ax square graph. The magnitude of A means what? The number value of A tells whether it is a vertical compression or stretch. Compression or stretch. When do you call it a compression? When the A value is less than 1, when it is a fractional value, it's a vertical compression. When the A value is greater than 1, it's a vertical stretch. Any questions on this? Okay, now the sign, right? Meaning A value less than 0, then it becomes a negative value. A value greater than 0, negative value, then it indicates a negative value. This indicates a positive value. So if it is a negative value, it's a reflection on x-axis. Okay, this A is greater than 0, nothing. That's our parent graph, meaning that's the original graph. A is less than 0 means this becomes C. This becomes something like this. So there is a reflection on the x-axis. Got it? Now, if I say y equal to 1 by 3 x square, it's a vertical. What is that? Vertical
Compression.
compression by a factor of 1 by 3. So for this week, let me finish it off here. Suppose if I give you this, would you be able to write an equation for the graph? Let's check it out. Suppose I have a graph. I'm saying that this graph passes through the point -2, -8. -2, -8. I would like you to write the equation of the graph. What is the format for this one? Y equal to, what is the format? You tell me, what is the format of this graph? Ax square, can I say?
Yeah.
Wouldn't the A be negative? Because
Yeah, A will be negative, but when you find out what is the A value, you will get a negative value. That will tell you you're doing it right. You got it? So general format, but they've given a point, right? Make use of it. How can you make use of it to find out the A? This is x comma y, right? Can I substitute like this? Can I substitute like this?
yes.
So when I substituted C, this is minus 8 equal to 4A. A will be equal to minus 8 by 4, which is minus 2. So the equation of this graph is y equal to minus 2x squared. You got it? So this is very easy. Provided make use of this, plug it in, find out that A value, then write your equation. Make sense?
Yeah.
Guys, do you want to do one problem on that, or I'll let you go? What do you want me to do? I'm okay with anything. What do you want to do? Please, you have to tell me quickly.
I'll just do
Another.
Let's do one problem. Okay, I can be quick. So see here, this is the graph format. I'm going to draw a graph for you. This point is 2, 2. Now, can you find out the equation? Just send it to me and go. Equation of this graph. You have to find the equation of this graph. I've told you the general format is this for now. Okay, because you're all starting, right? I'll give you the format. Now, just tell me the equation of the graph and then you can leave. You have to find the A value. Make use of 2, 2 as x, y. This week's homework will be easy. Maybe I did not say about the y-intercept. Y-intercept is the point where the graph cuts the y-axis. Yeah, try doing. Anyway, we have done enough, I feel. Just get me the equation of the graph and then you can. Guys, is it difficult? Anya, for you?
Priya, do I just send it in chat?
Yeah, please. And if you get it, you can leave. Oh, that's right. Good job, Pranav. You can leave.
Fine, Priya.
Okay. Who else, guys?
I sent it.
Yojit. Correct, Yojit. You can leave, Yojit.
Um,
Navya,
Yeah.
good job, guys.
Sorry, what's the question? I was using the restroom.
The equation of the graph.
Miss Priya's mine, right?
Navya, yes. Uma? Adira, correct. You can leave, Adira. See you next week.
Thank you.
Miss Priya, I sent my answer.
Yeah, I saw your answer, Rishit, but that's not right, right? Did you miss something?
How do you do it again?
Okay. Okay, Anya, if you had not followed, I'll do it for you. But Mahir and Srinita, do you have the answer? Srinita has it. Go ahead. Go ahead, Ma. Bye. We can see you next week.
Bye, Miss Priya.
Mahir, that seems incorrect to me. Yeah, you are substituting it correct. So what Mahir should see here. X and Y, I'm just substituting 2 and 2. When I substitute, this becomes 2 is Y. X is 2 means A times 4. So A equal to 1 by, what is going on, guys? This is 2. So A equal to 1 by 2. Am I making sense?
Yeah.
Put it back into the equation. Y equal to half x square is my equation. Okay?
Okay, thank you. Bye.
Thank you. Bye.
See you next.